All right, now that we understand how to solve linear equations, um, there's a couple of like outliers. Like what happens if we have an equation that's true all the time? An identity is an equation that is true for all values of the variable. And then the complete opposite of that is called a contradiction. That's an equation that has no solutions at all. When you first start solving equations algebraically, we kind of don't know what we're going to come up with. So everything we've come up with or we've come across up till now, we've got an answer like x equals 3 or whatever. We're always able to get an answer. So I want us to understand when algebra is telling us something is up. So let's start solving this one. And again, I'll just go through the steps a little quicker. But the first thing we're going to do is simplify our expressions. We're going to work with each expression and simplify it. So on the left side, I got two terms. I have a 2x, and then I'll need to distribute the negative 3 to each of these terms. I'll end up with a negative 15 here, negative 3 times 5, and negative 3 times negative x is a positive 3x. So the left side ends up being 5x minus 15, and then that equals. So the right side, again, I have three terms here. This one I'll need to distribute 2 times 2x and 2 times negative 4. So I end up with two terms. I end up with a 4x and a negative 8. Then I have plus x and at negative 7. So when I combine my terms together, I get 5x. Negative 8 and negative 7 is negative 15. And I realize, and this is kind of a red flag here, that's my red flag. I realize that the expression on the left is exactly the same as the expression on the right. We have exact or exactly the same expressions. If they're exactly the same expressions, then it doesn't matter what value we'll have, the values will come out the same on both sides. Does that make sense? So no matter what I plug in, the left expression is going to give us the exact same value as the right because they're the exact same expressions. Now, if we continue and we think isolate the variable term, I might cancel out the negative 5 or zero out the 5x on this side. And by doing that, notice what I get. I have no x term, and on the right I get the same, of course, right? But what happens algebraically, whoops, no, the variable terms disappear from the equation. And we didn't do anything wrong algebraically. We attached the same terms, so that's legal. But we end up with negative 15 equals negative 15. And this statement is true all the time. It's never false, right? Negative 15 does equal negative 15. Therefore, this is an identity. And the solution is all, so the answer is all real numbers, meaning x could be anything. And we got a hint of that by seeing that the expressions were exactly the same once we simplified. So let's try another problem, maybe one that we have to practice a little bit with clearing fractions. Well, why not? So let's clear fractions here. We had a bunch of fractions in this. Let's multiply both sides by a number that will cancel everything, which is 12. 12 will cancel a 4 and a 3 and a 12. So if we multiply by 12 on both sides, the clear fractions, again, as we do this, we need to recognize our composition. So the first expression on the left has two terms. Because the first term, when I distribute, this is a factor, so I just need to multiply 12 times negative 1/3. The 3 is going to cancel with the 12, leaving a factor of 4. So you notice I have a factor of negative 4, and I have this factor of a plus 4 left. Right? So we could distribute that out now. After I did my canceling, we can distribute. This would be a negative 4a and a negative 16, right? Negative 4. When I distribute to the next term, the 4 will cancel with the 12, and it's going to leave a factor of 3. So this term would be 3 times a, which is just 3a, right? And if we combine our terms together on this left side, the left side becomes negative a minus 16 and negative 16. On the right, we'll distribute the 12 to the negative 1/12 a. So when we do that, the 12 in the denominator will cancel. Nothing is left but a 1. But what's the term? And the term, right, don't forget your negative, is negative 1a. So this would be a negative a. And then if I multiply the 12 to the 1, I get plus 12. Now here, if you look at this one, I don't have the exact same expressions. But if you look, each side, right, we have the same variable. Oh, I'll do this in blue. We have the same variable term on both sides. Okay, so as I simplify my expression, I notice I have the same variable term on both sides. If I continue to solve, I would want to isolate the variable term on both sides. Well, that means I would want to zero out one of these. I'm going to add a to zero out the a here, but I need to add a to both sides. And what happens, I'm left with, on the left side, I'm left with negative 16, and on the right side, I'm left with 12. So that the variable term disappears again. But in this case, I'm left with an equation that's false, right? Negative 16 is equal to 12. That's not true. So therefore, this is a contradiction. So the answer, and this is important, if you want to answer this, the answer is no solution. Remember, if you're solving an equation, you're trying to find values for x that work. And we found out that there isn't any. There actually will not be a value for a that I could plug into the original equation and get both sides equal, the same value. So the algebra is telling us, because we end up, as we solve, we end up with a false equation. The answer then is no solution. Okay? If we ended up with an identity where the expressions ended up to be exactly the same and we end up with a true equation the algebra gives us, then the answer is that all real numbers. X can equal all real numbers. So these are the other possibilities you might come across when you're solving equations, right? When I solve an equation, I get an answer. That's called a consistent equation. But I could get an identity, And it all depends on, in my algebra, does it come down to a true statement as I perform the algebra to solve? Or does it come down to a false statement when I perform my algebra, when I do this algebra? And if it's false, it's no solution for an answer. Okay.